You can see here is an image representation of a genetic algorithm. Basically the same process. Now you see the mixing and matching creates a new identity. That's how your DNA twists left and right, having different combination of proteins and structures. From two sperms. So you see they have replaced the all those digits which they usually use A, G, or I don't recall the others for genes with the binary system 100110010. Now this genetic algorithm, any information you feed it, it changes it into a binary system and does the mutation crossover, then creates it makes the data evolves and it finds more information in the data and can also make it gain structure. Like I've said, you can see that they are using it also in animations and things like that, where they teach an AI to walk. You see here is the implementation in the structure of the algorithm, which basically comes from the biology of nature. Where they use a fitness function. It depends with what you're trying to reach the optimum solution. It tries to find the best. Genetic algorithm is used for problems in which you can't exactly know what's the answer, but you can kind of go towards the right direction. Something can guide you towards the right direction. So the bigger the data you have, the quicker you arrive at the solution and the more optimum solution you have. Or even lesser, it depends with how you are approaching the data and what you're trying to do with it.
Evolved to perform specific tasks in simulated physical environments. Swimming speed. This demonstration shows virtual creatures that were evolved to perform specific tasks in simulated physical environments. Swimming speed was used to determine survival. Most of the creatures are results from independent evolution. Some developed strategies similar to those in real life. Once they're evolved, multiple copies of these creatures can be made and simulated together in the same environment. The next group of creatures were evolved for their ability to move on a simulated land environment with gravity and friction. Some simple solutions with just two parts were found. Some seemed like they could use some assistance, while others were fairly efficient, such as this rowing-like behavior. Here is an odd cousin of the previous. A mutation caused him to tumble. Some creatures evolved to incorporate contact sensors in their control systems. Here is another inchworm-like creature that tends to go in circles. This was actually a creature first evolved for its ability to swim in water, then later put on land and evolved further. A successful sidewinding ability resulted. Here is one with a hopping style. The protrusions on its arms seemed to help prevent it from tipping over. This was the fastest, with a successful galloping-like stride. This group was evolved for their jumping ability. This group was evolved for their ability to adaptively follow a red light source. The resulting creatures are now being interacted with. A user is moving the light source around as the creature behaves. This one seems to flail randomly, but somehow still manages to approach the light. Perhaps it is mean to move just as it arrives. Here is one that has propeller-like fins which are tilted depending on the direction of the light. It can adaptively swim up or down very well. This final group of creatures was evolved for their ability for control of a green cube. The creature closest to the cube at the end of a simulation is the winner.
Now you see
Here, a strategy first arose for simply
the kind
tumbling
of things
towards
they're
the
getting
cube.
from imitating nature.
Then one learned to block out his opponent.
It can be applied in different ways. And this is what I was
But
talking
then
about,
later one learned
determinants
to overcome the
that
obstacle
determine our
by climbing
traditions.
over it. Some pinned down their opponents.